Hi, I'm Raymond Hunter, and this video is about the most effective way to permanently stop making careless errors in math. Many people think the most effective way to stop making careless errors is just by doing a ton of repetition, but it's not. The most effective way is to first understand why our brains make it so easy for us to make careless errors in the first place, and then to develop the mindset and the skills necessary to stop making careless errors. Think about all the points you've lost due to careless errors throughout all your years of your math classes. I'll bet it's a ton. And then how many times has your grade on an exam been 1 to 2 full letter grades lower strictly due to careless errors? Eliminating careless errors is one of the easiest ways to get a huge boost to your math grade. And once you learn how to eliminate careless errors, they don't come back. So your grade boost continues year after year. The first thing I'm going to do is explain how our brains make it so easy for us to make careless errors. And the second thing I'm going to do is walk you through an example while sharing a mindset and skills that you can then use and adapt to eliminate careless errors on many kinds of math problems. Here's why it's so easy for us to make careless errors. It is a scientific fact that your brain can only keep track of a few pieces of information while also trying to solve a problem. Your brain's working memory is where the problem solving occurs. It's the place where you temporarily hold and manipulate small amounts of information while also trying to perform complex tasks like solving a math problem. You're probably totally unaware of how much you're even juggling when you're solving a math problem. You have to remember what the instructions said. You might have to apply multiple math rules simultaneously. You have to remember and apply arithmetic basics. You have to remember where to look as your eyes dart between the problem and your writing. You have to remember the answer while you're writing it. Even the act of writing uses your working memory. And finally, your working memory is where you actually figure out how to solve the problem in the first place. Now I'm going to walk you through solving a problem using a highly effective mindset that takes the load off your working memory and stops careless errors. All right, let's do it. Here's the first example we're going to work through. The instructions are to simplify this algebraic expression. Usually we simplify expressions and we solve equations. Remember, equations have equal signs and expressions don't. There's a lot of room for careless errors on this problem because there's a million little steps you got to do, and a lot of the steps require multiple rules being used at the same time. So the techniques that I'm going to show you here, sure, you can use them on similar problems, but ultimately your goal is to develop the mindset from what you learn here that you can adapt and use to solve any careless error situation that you come across. The first thing I'm going to do on this problem is scan all the variables to see if each one has an exponent. So I look around, I look over here, and I see the z does not have an exponent. I look over here, and I see the x does not have an exponent. So what I'm going to do is I'm going to give each of those an exponent of 1, because z to the 1 is the same thing as z, and x to the 1 is the same thing as x. And later, this will definitely help prevent careless errors. So over here, I put a 1, and then over here, I put a 1. Okay, so that step's done. Now I'm going to scan the problem to figure out the next step. So I look at the first part and I notice it has no exponent. Then I look at the second part and I see that it does have an exponent. So I'm going to make the decision to work on the second part, and the first part remains untouched. And since I'm not doing anything to it, I'm going to simply write it below. There it is. So that my mind is free and clear and I don't have to think about that. I can focus on the second part only. But before I go to focus on the second part, I'm going to really quickly make sure that I actually wrote that down correctly. So I look up here, negative sign here, negative sign there. Looks good. Now the next guy, 3 here, 3 there. Looks great. Next guy, x to the 4th here, x to the 4th there. Looks great. Next term, y squared here, y squared there, looks great. And finally, z to the 1 here and z to the 1 down there. Looks great. Now I will begin on the second part. I have to give the 2 that's the exponent on the outside to each item on the inside. So I have to give it to the z cubed, the y squared, and the x to the 1st. And then I have to give it to the 4, and I have to give it to the minus sign. The rule for giving it to the variables, those exponents that are in the variables, that's one rule. And then the rule for giving it to the 4 is another rule, and the rule for giving it to the minus sign is yet another rule. So there's 3 different rules, we have to be really careful to make sure we use the right rules at the right time. And the next step I'm going to do is write a set of parentheses down below. Here we go. And it serves as a container for the new work that I'm about to do. Now I'm going to give the square to the minus sign, and I'm going to write my answer down here. So when I square a minus sign, I get positive. So I'm not going to bother writing a positive sign. Next, I'm going to deal with the number. I give the square to the 4, and I'm going to write the answer down here. So 4 squared is 16. Now that I've written it, I'm going to pause for a moment. I'm going to really think that through. Is 4 squared really 16? See, my mind is clear now. I'm not bothering writing. It's free and clear. That's the only thing I have to think about. Is 4 squared equal to 16? So I think for a moment. I go, yes, it is. Okay, so that part's good. The next thing is I got to give this exponent, the square, to each of these variables. And when I do that, the variables themselves, they don't change. So what I'm going to do is I'm going to take these variables, x and y and z, and I'm going to put them down here. There they go, x, y, and z, so that now I don't have to think about them. And the rest of the work, all I got to do is focus on the exponents. Now, when you have an exponent of an exponent, you multiply the exponents. So the first one is I've got a 1 here and a 2 there. I'm going to put my answer down here. So 1 times 2 is 2. I write that down. I pause for a moment. I say, is it really 2? 1 times 2 is 2. Yep, it is. Okay, on to the next one. So I have a 2 here and a square here, and I'm going to write my answer down here. So 2 times 2 is 4. I write the 4 down here, and then I pause for a moment. I go, is 2 times 2 really 4? Yes, it is. Okay. Next step, I've got my 3 here and my 2 here. I'm going to write my answer down here. So I say 3 times 2 is 6, and I write the 6, and then I pause for a moment, and I say, is 3 times 2 really 6? Yep, it is. Okay, so I'm good to go. This idea of checking your work as you go saves you a lot of headache down the road, because if you get to the end of the problem and you realize, oh my gosh, I made a mistake early on, well, you could go back and try to patch your work. A lot of times that doesn't work out so well. A lot of erasing, a lot of rewriting, things you don't think through. Or you can try to redo the whole problem, but either way, it takes a lot of time. Now, I realize this seems rather labor intensive, but honestly, you can do it in an instant. It just becomes very robotic and you don't even think about it. It's a really good way to go to save time and make sure you get the right answer later. Now, on to the final step. We have 2 sets of parentheses next to each other, and when that is the case, it means to multiply. Now, I'm not going to deal with that minus sign just yet. What I'm going to do is I'm going to focus on the numbers first. So I have a 3 and a 16. So, and when I'm 3 times 16, I'll write my answer down here. So 3 times 16 is 48. So I write the 48, and now that that's free and clear, I'm going to focus on, is 3 times 16 really 48? So think about it. Yeah, it's 48. Okay, we're good to go. Okay, so for the next part, we have these variables that we have to put together. And the variables themselves, once again, they don't change. So the x, y, and z, they don't change. So what I'm going to do is I'm going to transfer them down there. There we go. And now my mind is free and clear to focus only on the exponents. In this case, when you have 2 of the same variables being multiplied together, you add the exponents. All right, so we have an x to the 4th, we have an x squared, so we have the 4 and the 2, and I'm going to write my answer down here. So 4 plus 2 is 6. I write the 6, and now it's written. So once again, I pause and I think, is 4 plus 2 really 6? Yes, it is. Okay, so the next step is I have my 2 here, and I've got my 4 here. I'm going to write my answer down here. So again, I add. So 2 plus 4 is 6. I write the 6. And after I've written it, I pause. Once again, I say, is it really 6? So yes, it is. Okay. So the final step is I've got my 1 here and my 6 here. I'm going to write my answer here. So 1 plus 6 is 7. I write my 7, and then I pause for a moment and I ask myself, is it really that? Yes, it is. And then finally, let's not forget about that minus sign. So now I have only one minus sign. Everybody's being multiplied. So I simply transfer that minus sign down here. And now we're good to go. Answer is all good. Thanks for watching this video. If you found it was helpful, consider liking it and subscribing to my channel so you can stay updated on new content. You can also drop a comment below because I'd love to hear your thoughts and any suggestions you might have for future videos.